Okay. Hey. Okay, hi. All right, so give people a minute to get a seat or to vacate the premises. Okay, hi. So this the title of this talk is called "You Can't Make a Denver Omelet Without Breaking Eggs: Using OpenStack Policies for Great Good." Okay. My name is Brian Rossmeda. I'm a senior software engineer at Red Hat. I've been working on OpenStack since Folsom. I've worked mostly with Glance. Now I'm working with Cinder. And I am both the oldest and the youngest Cinder core at this point. This is sort of a through the looking glass thing, but this is the actual title of the talk. So hopefully this won't scare anybody away. But really what this is about is some remarks about policies with special reference to Cinder and Glance, because that's what I know the most about. So some remarks, so this is mostly me talking, but I want to point out you've got a great opportunity this afternoon to try any of this stuff out with some expert help available to answer questions. There's an access control policy hands-on lab at 350, meeting room level 4D. Harry Rabaki, Adam Young, and Nathan Kinder from Red Hat, who are up here, are putting it together. So the focus is on learning and practicing techniques so that you can customize the policies in your cloud. Should be fun. You get a pre-configured VM, and away you go doing whatever. So I don't mean to give the impression that it's like the practical part of this talk, but it's related in that I'm going to present mostly how you can do some stuff with policies, and you'll have a chance to try that out and learn some more techniques about how to deal with policies that I'm not going to be talking about. I'm going to move kind of quickly because I want to cover a lot of stuff and just because I talk fast anyway. But a lot of this talk is drawn from a how-to guide. So there's a place you can go and look to fill in holes if I forget to mention something or to go over some details. But if you go to cinder.openstack.org, you get the home page. Go to the operators section. There's a reference section. There's a section on configuration, and then there's a policy how-to, and that's got a lot of information in one place for you. Okay, so the intended audience for this talk is operators, because you need to be in a position to configure an OpenStack cloud if you're going to make use of this information. Now, one interesting thing is anybody who cranks up a dev stack or a pack stack or whatever your weapon of choice is automatically becomes the operator of an OpenStack cloud. So even if you don't currently have a cloud of your own or somebody you're working for, you're thinking of deploying a cloud, you can get this kind of practice. I personally am not an operator.
Yes,
so I guess I'm an operator like slightly removed, I guess, I don't know. But the premise of this talk is that if you understand how developers think of users when writing code, it's going to be much easier for you to configure your own custom policies. So that's the main thing. So I'm a developer. I think about these things a certain way when I'm doing code, and the policies are sort of, we'll see. I've got there's a model in my head that I work with of users that's kind of not related directly to the policies. All right, one thing I do want to point out. So this talk's in the security track. So you can configure policies that will make your cloud much more secure. But it's remarkably easy to use policies to make your cloud insecure because they're complex, and it's possible that you may have unintended side effects for what you do. So I just wanted to stress, this is some dangerous stuff we're talking about. That's why I really encourage you to go to the policy lab to see what an environment's like where you can experiment with this stuff in the comfort and safety of your own home. Here's a quick assessment for whether you should consider this complex or not. You may remember De Morgan's laws, right? The negation of a conjunction is logically equivalent to the disjunction of the negations, or the negation of a disjunction is logically equivalent to the conjunction of the negations. If you don't remember or haven't heard of those, you need to be extra careful when you're doing this stuff, because when you write the policy rules, you're using some basic logic. If you are familiar with those, I think you should also be extra careful, because it's really hard to visually see that what you've done is correct. So again, I just said this, but I encourage you to attend the hands-on lab so you can experiment with this in a safe environment. But the key point, well, the second key point, if you're going to make policy configuration changes in the cloud, you must have a test plan in place. You can't visually inspect these things. I mean, what I've got here, I just tried to figure out how long would a logic test be, in college if you're taking Introduction to Propositional Logic or something. And if you had 75 questions on a test, my students would probably lynch me. But that's a lot of questions, but it's reasonable to do it in 50 minutes possibly. The Cinder policy file by itself has more than 75 policy targets. I stopped counting when I got to 75 because that seemed like a good number. And there was a bunch more stuff in there. So the thing is, did you get 100% on all your propositional logic exams? Maybe. If you did, congratulations. If you didn't, you're still a good person. But the point is, if you didn't get 100% and only got like 95, I mean, one of the consequences of getting a 95 on a logic exam is not that some user is going to be able to delete other people's stuff or run riot in your cloud. So we've got some major stakes here. So I just want to emphasize that. Okay, so here's the outline for how this is going to go. Give you some basic background and vocabulary so it's clear what we're talking about. I want to talk about something called the administrative context. Then I'm going to give a very, very extremely short history of OpenStack policies. I stress the shortness because I once gave a talk on the evolution of the glance image APIs. Anyway, how to find out what the cursed policies are, which is good for you to know. How to modify policies. A few things about glance and policies, because glance is a little bit atypical from Cinder. And then I want to walk through an example of configuring a read-only administrator, which is something a lot of people want to do. And it is possible to do it, but you need to be careful. Okay, so policies. Well, what they do, they just allow you to control how users and administrators, so it's basically anybody who's communicating, is interacting with services that you provide in your cloud, you can control their interactions. And they do this because each service defines a set of policy targets that the service will respect. It's like a contract. And so each target can be associated with some specific policy rule, and that must be satisfied when the service enforces the policy. Right, so, and each policy can refer to roles that you define in Keystone, and then in Keystone, you can take these roles and assign them to users. So that's how the whole thing sort of hangs together. So just not to get too abstract, this is what an actual Cinder policy looks like. And you got a thing in quotes on the left, a colon, and a thing in quotes on the right. So the thing on the left is what we're calling the policy target. So that's provided by the service. And then the rule on the right goes in quotes. And then how exactly rules are defined, you can learn if you go to the hands-on lab. It's the way the Oslo policy engine recognizes these things. So there's a precise syntax defined for this. But this is in general what we're talking about when we're talking about a policy. All right, so the policy targets are service specific. So each service defines the set of targets it's going to recognize. And then the policy rules are specific to the policy file that you are using to configure the policies for that service. So basically, the targets that appear in the file are predefined by the service, and then the rule names are pretty much whatever you want to do. And that's how you control what's going on. Okay, so some vocabulary. Anyway, so a project is just an administrative grouping of users into a unit that can own cloud resources. All right. In the old days, we used to call this a tenant, and then people decided that was a little ambiguous, so we went with project, which turns out to also be ambiguous. So that's why I'm giving this little vocabulary thing. So what I'm going to talk about are services. So an OpenStack component that interacts with users through an API is a service. So for instance, Cinder is a service that provides the block storage API, and it also provides other components that help satisfy the requests that one would make to the block storage API. Glance provides the image API. So Cinder and Glance are sometimes referred to as OpenStack projects. Like there's the project team gathering that's happening at the end of this week. But I'm going to refer to them as services in this talk because it gets kind of confusing when you start mixing things together. Anyway, if you're new to OpenStack, this isn't a problem because you've never talked about tenants, you've always talked about projects, but I just wanted to bring this up because in talking to people, sometimes they're a little vague on what you mean when you say project. Okay, now here's the key thing, the user model. So when developers are writing code, they expect that they're going to interact with two kinds of users. So the first kind is just the end user, the normal people. So they consume resources and pay the bills. They're restricted to acting within a specific project or projects of which they are members. And they can't perform operations on resources that are not owned by the project or projects that they're in. So that's pretty normal. And then on the other hand, we have administrative users, called admins for short. And admins can view all the resources controlled by the service. And they can perform most actions on them. So for instance, sometimes users get a VM in a state, they don't know how to delete it, they call for help, and the admin can go in there and delete it. There are various things that admins can do. Or a customer might need help putting metadata on an image, and an admin can do that for them, even though they don't actually own the image themselves. Okay, so administrative users also usually have access to operations that cannot be performed by end users. So like setting quotas, for instance. We don't want end users to set their own quotas because that would be chaos. So we don't, so administrators do that. And then administrators may also be able to view resource properties that can't be seen by end users. So for instance, properties of a virtual machine, like the host that it's on, you might not want to expose that kind of information to end users because they're supposed to think of these things at a more abstract level. But for administrative purposes, you may need to know exactly where that thing is located. So administrators can sometimes see information on resources coming back from a call that normal users can't. So that's pretty normal. That's what we'd expect. All right, so now the administrative context. So OpenStack APIs do not in general have a special admin API, right? An admin or an end user who wants to do a volume list, just see how many volumes there are, or wants to see the details about a particular volume, make the exact same call, okay? But they see different responses because when an admin does it, you can see all of them, whereas if you as an end user do it, you just see yours, right? So the difference is that one call is being made in an administrative context and the other is not. So basically, a user who's acting in an administrative context can do admin type stuff, right? Which is a little vague, but you have the basic idea, hopefully. And a user who's not acting in an administrative context can only do normal end user type stuff. Okay, so this brings you what an operator can do with policies in OpenStack. So an operator can define what users are granted the privilege of acting in an administrative context. All right, and then an operator can specify for specific policy targets which users can perform those actions. So in general, an operator can define who can make calls in an administrative context, right, by using Keystone in the policy configuration file. But an operator really can't affect what can be done in an administrative context because that's been determined when the code's written, right, independently of the policy file. So when you're acting in an administrative context, certain stuff can happen, and if you're not acting in that context, certain stuff doesn't happen, right? Which is a very simple point, but the key thing here is that you can't, well, I think that's probably what I'm about to say on the next slide. Right. So here's an example. So in Glance, the boundaries between projects are strictly enforced, right? So there's only an administrator can view resources across projects, right? So if I can't see your stuff in Glance unless I'm an administrator. And there's no way to grant an end user the ability to see into another project using policies. I mean, what I could do is if I make you a member of that other project, you're going to see that project stuff, but that's appropriate because you're in that project. But normally, if you want to do a list of the images owned by a project that you're not a member of, you can't do it. Unless you're an administrator, then an administrator can do that. So that's enforced because Glance has this model of we have an administrative context in which stuff happens, and we have a regular user context. So I've been asked in IRC several times about how do we configure Glance policies so that an end user can only do stuff on their own project, right? Because they go and, I'm probably about to show this in the next slide. They go to look at the policy file and it's like anybody can make this call and they want to say, but I don't want anybody to do this. I only want my users to see the stuff that they actually own. Well, that's built in, that's independent of the policy. That's how it works out of the box. So the key thing is that A user can do admin type stuff only if they're acting in an administrative context. So that includes simply reading stuff that only an administrator can see, right? So this is because there are checks throughout the code and not simply at the API layer where you're making the request to determine whether or not processing is happening in an administrative context, right? So think of it as when you request something, what happens is an object gets passed around to all the components of Cinder, say, and they all slap stuff together, and eventually you get a response. So as they're building the response, they need to know, are you acting in an administrative context or not? And that affects what gets constructed there. And so this is what I was talking about with Glance. So Glance has a policy target named getImages, which, as you expect, allows you to get the list of the images. And in the policy file, it looks like this. So the target is get_images, and then the rule is empty. And that means anybody can do it. But what that actually means is anybody can make this getImages call, right? But in the code, it's restricted that you're only going to see the images that you own, unless you're an administrator, and then you can see across projects. So basically, the key point is you can restrict who can make that call, but you can't change what's going to happen when that call is satisfied, right? Okay, so I hope I'm not banging this into the ground too much. A lot of operators are interested in having an observer or a read-only administrator who could conduct audits, say, but not modify anything, right? So follow the principle of least privilege. It's a good security concept. You really do want to do that. But the point here is, to create a read-only administrator, you're going to have to allow that person to make calls in an administrative context, because that's the only way to get the information you want that person to see out there. You can't just take an ordinary user and just add one or two admin type properties, because we don't have a list of what an administrator can do and just say, hey, give this guy this abilities. It's just, you're acting in an administrative context or you're not. It keeps the code simple, which is kind of nice, but you run into this problem where it would be nice if I could just have a little checklist and say you can do these things. Now, we can make that happen, but we have to do it by configuring policies. And that's what this talks about, right? So you're going to have to allow, so if you want a read-only administrator, you've got to let that person be an administrator. All right, now that's bad because now they can do everything. They're a super user for that service. But once you've done that, you go back and you plug up all the holes and say, all right, I'm only going to let this person make the calls that allow them to read stuff. I'm not going to allow them to make any calls that do updates or deletes or creations. And that's basically how it goes. All right, so some remarks about policies is what we're talking about. So that's the theory part of the talk, is just that point about the administrative context. So now we'll look at some practical matters. We'll look at what a policy file looks like, talk about where to find a policy file. Glance is a little bit special in how it handles policies or uses them maybe, so we'll talk about that a bit. Cinder's pretty normal, so although that may be, there may be some people may not think so.
Normal from a Cinder perspective.
Right, so it's, okay. Cinder, well, let me put it this way. I work mostly with two services, and Cinder is the more normal of the services I work with. How's that? So anyway, so I'm going to use Cinder as an exemplar of the other services. So the general point I'm making can be applied to other things, but I'm going to be specific in this talk because we've got some limited time, and also because you have the opportunity to go to the lab later at 3:50 this afternoon and check all this stuff out. And then I'll do a walkthrough of a practical example about configuring a read-only administrator. Okay, so here's the extremely short history of OpenStack policies, and it'll become evident why we care about this. So the Oslo.policy library appeared in Kilo, and what that did was it made the policy configuration more uniform across services. So policies sort of evolved as part of OpenStack, and that's also why the model might not be as nice as we would like. The original policy files were written in JSON, which is nice. It's, you know, everybody knows how to read JSON. YAML support was introduced in Oslo Policy 1.10.0, which came out roughly in the Newton timeframe. But it wasn't announced until 1.15, which is in the Okada timeframe. Now, the only reason I'm talking about that is I'm going to, well, YAML, right? So with YAML, you get to do comments, whereas with JSON, you don't. And that's a problem with this kind of thing where we've got complex configurations we want to make, And if you get hit by you might get a great thing done. You get hit by a bus, the next guy who has to maintain whatever it is you put together is going to be kind of clueless. So it is helpful to have comments in there, or at least the ability to have them. So that's why the YAML change was big. Now, well, I'll talk a little bit more about that, but I don't know. So I don't know if you're still running Newton, which many people are. I believe you could use a YAML policy file, but I personally haven't tested it out. So just be aware of that. But I'm going to talk about YAML because the ability to have comments, is a big thing. Now in Queens, there was a policies in code community initiative. So before that point, each service shipped with a policy file that gave the defaults for all the policy targets for how the developers thought you should interact with this service. And then what you would do as an operator is go through and fix it to make it reflect what you wanted the reality to be in your cloud. Now, in Queens, policies were moved so that they're defined in the code with defaults right there. And you have the ability to run without a policy file, which is nice in some ways if you don't want to worry about this. There's sensible defaults, as we say, so you pretty much get a cloud that does more or less what you want. But if you want to make changes personally, you need a policy file to work with. So I'll talk about that in a minute. Glance did not participate in the policy and code initiative, and I was PTL of Glance at that point. So if we have time after this, I can explain why. But anyway, so Glance does need still ships with a policy file, and it needs it to get sensible defaults. Yes?
Is there a nice way of reading those defaults?
I'm sorry?
Is there a nice way of reading those defaults in the code?
I'm sorry, I couldn't hear you again.
Is there a nice way to read the defaults in the code?
No. Well, not in the code. You can go to the code directly. They're right there. They're easy to find. And I'm going to talk about how you generate the policy file. It's a good question, and it probably gets to the next slide because you can generate the policy file for all the teams that did put the policies in code. There's a way to just generate a sample file that's completely commented out, but each one will have the defaults. And if you go to the lab this afternoon, that's part of it. You'll see how to do this. So the downside, I don't know if it's downside or not. Anyway, you have to check out the code, and you have to have some stuff. You've got to be able to run Tox in your environment. So you need to have Python, you need to have Tox installed and its dependencies, which I'm not sure what they are. So as a developer, this is like the easiest thing to do, but as a normal person, it might be a little problematic. But anyway, you can generate the policy file. And then this is slightly edited so it would fit on the slide. But you just generate the policy, and then it shows up with the source code, and then you just go look at it. It's just called policy.yaml.sample. So it's a YAML file because it's got comments. You need to have comments in it so you can explain what it is. And the policies look roughly like this. You have a comment that says what it does, a comment that says what API call it's associated with, and then the actual policy target followed by the default rule. So we can see for the first one, for attachment create, that's unrestricted. Anybody can do it. But if you were paying attention earlier, you realize I can't actually attach something to somebody else's stuff because I'm not operating in an administrative context. And then if you look at the next one, to update an attachment, you do the put attachments and the attachment ID, and then the admin or the owner can do that. All right. Okay, so configuring a policy file. I think the best way to do this is to tell the service what policy file it should use. Because the reason why is because for most services, since the policy file is optional, if you configure it to find a file and you put the wrong location, the service isn't going to know that. It's just going to say, the file's not there. I know all the defaults, and it'll go ahead and do it. The problem with that is it's using the default values, not the ones you've carefully set. So if you do modify, this is an optional step, but I think it's a best practice, is just go ahead. You need to find the Oslo_policy stanza in the configuration file and just set the policy file configuration value. And I would set it to an absolute path because then you know for sure, right? You don't want to leave anything up to the code to try to figure out what you're doing because, right, in the worst, we're working in a realm where, right, the worst case is when stuff doesn't crash and burn immediately, right? Because if stuff is running, but it's doing something that you don't intend, that's really bad because that's where all those eggs get broken and you wind up without an omelet. Okay, now with the glance policy file, the file that ships with glance is JSON. But glance uses Oslo policy, that library that most of the services use, so it can understand a YAML file. So if you're going to configure glance policies, you can just work in JSON if you want, but if you want to take advantage of having comments available, you can use it in YAML. And this was the point I made earlier about, I'm not sure if you could do this with Newton or not, so you might have to check. But I do know that in the recent versions of OpenStack, all the supported ones upstream, you could do this. Now, if you want to do the conversion, there's a couple of things you have to watch out for. First, you just remove the opening and closing brace that are in the file, and that makes it no longer valid JSON. And then you can remove all the trailing commas, because you need those in JSON, but you not only don't need them in YAML, you don't want them in YAML because it'll cause problems. And then what I discovered in trying this out is the metadef policies all are target, colon, and then no space, just an immediate, quotation marks for the rule. And that's perfectly okay in JSON. But in YAML, it makes the processor we're using barf. I don't know if it's not legal YAML or not. I won't take a stand on that. But anyway, if you do want to convert to YAML, you've got to go ahead and put a space. Yes.
There's an online tool.
Oh, okay.
To do JSON to YAML, and that's what I've been using.
Okay.
It's worth doing it that way. Have some sort of.
I would agree. Yeah, because otherwise you restart the service and it barfs, and you got to restart it again. Figure it out. So yes, so better idea. Use a service that will automatically convert JSON to valid YAML. You'd add the comments and then make sure you configure the glance API.conf that you're using the YAML file instead of the old JSON file, and then away you go. So that's what you could do with glance. The other thing you could do is file a bug with, I don't see anybody from glance here. You could file a bug and just say, why doesn't it use YAML by default, since it's perfectly good, but that's a different point. Okay, all right, now here's a warning about working with glance. And this is one of those legacy things that we're sort of stuck with, but I just want to bring it to your attention. So with all the services, so we've been talking about the administrative context. Now I didn't point out in that sample Cinder file, right, the very first line was defining context as admin. Well, that's how you specify who's going to be able to act in an administrative context when calls are made. So all of OpenStack services have adopted that. And Glance has too. So if you go to the default Glance JSON file, you'll see context as admin is defined right at the top. But Glance has this other option that's a little weird called admin role. And what that does is it allows you to specify any role name, and then that overrides the context as admin, in the sense that anybody with that role, even if it's a stupid role, becomes an admin. Now the reason I'm bringing it up, now the default value is admin, which is sort of okay because the default usually is role admin is what you give to admins, and you don't give it to people you don't want doing admin type stuff. But as things get more complicated and you want to have different administrators for different services, say, things can get a little confusing there. So I suggest changing, even if you use admin in your cloud, I would suggest going to your Glance. So this is the glance-API configuration file. I'd go in and change it like I've demonstrated here. Just change it to a role name that is never going to exist in your cloud. Now, how do you know that? So my suggestion here is to, right, if you have an administrator who's running your Keystone, who creates role names that are called not a real role name, then, right, you need to have a talk with that person. But the idea here is that just do it. Now, I slapped a UUID in the middle just because I don't want everybody at this talk to use the exact same string, because you can right? Think about that. But anyway, the point in doing that is if we put a role name that's never going to exist, then we don't have to worry about looking in two places to understand why our policies aren't configured properly or something. So just something to know about. Okay, and then one more Glance thing. Glance has this thing called property protections. I don't know if anybody's used them here. What they do is they allow you to put CRUD permissions on individual image properties, the custom ones that users can put on their images, or that you as an admin might. The use case for this was that administrators needed to put licensing information on images so that things would be billed differently depending on which image you used. And you didn't want customers to go through and mess with those and be able to change them and get themselves unbilled or something. So we have that, there is that ability. You can use policies to define how the image properties are treated. Now, the reason I'm mentioning it is that you have to use the same policy file that you're using for your Glance policies. So if you're not using property protections, you don't need to worry about it. If you are, just be aware, because I'm bringing this up because I'm telling you, hey, you can use a different policy file for Glance. But if you do that and you want your property protections to work, you got to carry those over also. You don't have a different. The property protections use the Oslo policy enforcement mechanism to control this stuff, and that's why this stuff has to be in the file. So anyway, but my point is the best practice is to use dedicated rules for this because, right, your policies can get complicated enough. Since these are used for a specific purpose, it's probably better to just have specific policies for it. So let me just give you a quick example. So in your Glance, if you want to configure property protections, in your Glance API conf file, you specify the property protection file and the format, which can be either roles, so just a list of roles, or policies, which we're more interested in. And then in the policy file, I would just put some new policies, and I'd put PP for property protection. But you can make up some prefix just so that you know what these are for. And then if you're using the YAML file, you can use comments to describe what they're supposed to do. So here I've just defined three rules: everyone, members only, and special. And then I could refer to those in my property protection file. So when I went over to my property protection file, you can see me using those. So the way the property protections work is the file gets processed top down. The first match wins. And if the security model for this is pretty strict. If a property is not mentioned in the property protection file, then it is not displayed. So that's why at the bottom I've got the catch-all one with the dot star, where everybody is going to be able to see properties that match that. All right. Takeaway from this is that if you use Glance property protections and you want to use policies, the policy rules that you write have to be in the regular policy file with everything else. But I'm suggesting a good practice is to make them separate rules so that you can tune them entirely independently of your other policies. There may be some overlap, and developers hate overlap. We want to refactor everything. But in this case, I think it's better because the implications of having a bad policy that allows somebody to do something they shouldn't is horrible. So since the outcome is so bad, I think it makes sense to take a little extra care. Okay, other than that, Glance is completely normal and everything works fine. Okay, so now the practical application of all this stuff we've been talking about would be configuring a read-only administrator. So I'm going to talk about that. All right, so remember from the administrative context stuff, right? Even a read-only administrator is going to have to be an administrator. Okay, and an administrator is a super user for a service. So you've got to be really careful in doing this. So I want to stress that as many times as I can. So the strategy you can employ to do this is to introduce a new role. Yes?
Better way to do that.
Okay.
Because you're about to go into the policy.
Yes.
Roles are the wrong tool. What you really want to do is say, and there's two distinct mechanisms for this, because heaven forbid we should have a unified way to do it. The one that's available across the board right now is that you said admin project, which is beyond the scope of what we can go here.
Right.
Basically, it's a way of saying not only do you have the role reader as opposed to administrator, but that's on the admin project. So really what you want for administrator privileges is that you have that role on some special project and only on that project.
Right, okay.
And so, because otherwise, if I have admin, there's a long-standing bug, and it's been assigned to me forever, and I finally reassigned to somebody else. It's still open. Anybody know the number? I know, everybody knows this number. It's 968696. I wrote a song about it. Basically what it says is if you're admin anywhere, you're admin everywhere. And this is a security issue. This would be a CVE if it wasn't like the most commonly known issue. So one of the ways that you mitigate that is by making the admin context based on something there. Now, what's coming up now, what we're getting implemented as we speak, is this idea of a system role. So you assign roles not on a project, but on this thing called a system, which doesn't really exist, but it's another way of specifying the roles, and that's what you should use for moving forward. One of those two mechanisms. I know that's a lot.
Right. So like I said, please go to the hands-on lab later this afternoon, and Adam can explain this to you. I'm going to continue with what I've got because I got it, and also because this is backward portable, I think, to Grizzly if you stayed in JSON. Hopefully is anybody using Grizzly? Hopefully nobody, well anyway.
I might have a customer.
Oh man, all right, well anyway. So anyway, what I'm about to tell you is backward portable. Right, OpenStack is always evolving. Part of the evolution is that we get stuck with weird things, so we have to do quasi workarounds to make stuff work, and then we have new fixes come in. So as of right now, this is one way to do things. But as with everything, there's always multiple ways to do it. Again, I encourage you to go to the lab just so you get hands-on experience messing with policies, because like I said earlier, right, you have the potential to completely lay waste to your entire cloud if you don't do this properly. So you really want to practice and make sure you understand what you're doing. All right, so and you can see this, because the strategy I'm proposing is, hey, we need a read-only administrator, but that person has to be an administrator. Now what do? Well, we make them administrator, and then we don't allow them to make any of the calls that would let them screw things up. Right, and the downside of that approach is, right, I'm letting somebody do everything, and then I'm saying, oh, no, don't do these. And if I miss one, so that's the thing. So anyway, so the point about introducing a new role for this is you want to know exactly who this person is, who's the read-only administrator, because it's got to be somebody you trust, because if you make a mistake configuring things, they could delete somebody else's stuff. So you don't want, right, you want to know exactly who's got this, is the main point. Okay, so here's how we do this. So the first step is testing. Now, we haven't done anything, so how are we going to test? But if you think about it, right, a read-only administrator, you only want them to see the appropriate stuff. So you need to explain what stuff is. And one way to do that is to say which calls they should be able to make and which ones they shouldn't. You don't want a read-only administrator to do inappropriate stuff. So, right, it's one thing to have policy sets so they can do everything they need to do, but you also want to make sure they can't do anything else. And then you need to make sure that you haven't messed up the regular administrator, because they need to be able to do their job. So you need some kind of baseline for what an administrator can do by making calls in your cloud. And the same thing with regular users. You want to make sure that normal people can still do the stuff they used to be able to do. So you need to be able to set some baselines. And then if you've configured other types of users through policies, you need to, because once your boss hears, hey, I can make a read-only administrator, let's say, how about a create-only administrator? That would be a good thing. And then we could have these other guys who are just interns. They can only update stuff, but they can't create anything and they can't delete it, right? So you can imagine as you start to do this, I mean, this is a really powerful thing, and it's great, but right, what I was saying about the logic earlier, you can't just look at these rules and think, okay, I got it. I understand what this does. You need to have some kind of tests in place to make sure that the changes you make are actually the ones that you expect. All right, so anyway, so testing is really important. You got to figure out some way to do that. All right, and then step 2, create a new role. I think I already said this. I mean, why a new role? Well, this person's going to have full administrative powers for any functions we don't explicitly deny. So if we miss any when we're doing this, you don't want a rogue admin on the loose. You need somebody you trust, right? So that's the point there. Now for Cinder, so I'm saying, here's a role you could make up, Cinder : reader admin. So Cinder for just the service name, reader because they're reading stuff, and then admin because to remind yourself this person is able to do some serious things. Now again, just naming the role doesn't do anything to actually use it in the policy file. But you do want to have a meaningful name because it'll make things easier if you get hit by a bus and somebody has to continue the policy configuration without you. The small digression about roles, Adam will probably correct me about this because I'm not sure I'm saying this exactly right. But begin with Rocky, Keystone creates 3 roles out of the box that are available for you to use. And you can create more if you need to, but you get a member, a reader, and an admin. Now, beginning with Stein, which was just released, I believe the identity service itself is configured so that if you have the reader role, you have read-only access. But that's because the identity service was configured that way. As far as I know, nobody else was. I mean, I think that's an ongoing initiative. So I just want to bring that up because having the reader role isn't going to affect other services unless they've been explicitly configured.
That's a lie.
Okay.
If you have the reader role and you go into glance,
right.
That thing that you had there, how are those policies going to be evaluated? They would just check that you were in that project.
Right.
That you weren't admin, or actually ignore the admin contact. So if I give you the reader role,
right.
I'm just giving you change ability in glance. So the reader role is the same as the member role unless things are explicitly scaled down to it. All that stuff you said earlier about plug roles,
right.
at the project level stuff, the member applies there. So if you create a reader role and assign somebody a reader, yes, they can only read things in Keystone because Keystone's been smart about that.
Right.
They can delete images.
Right. Yeah, and I thought that's what I was saying, but maybe not. So the key point is there is a reader role that comes out of the box if you deploy Keystone. Keystone recognizes it. Glance doesn't, Cinder doesn't, right? So you could assign anybody you want that role. It's not going to do jack unless you go through and do the policy work to handle that. So I just want people to be aware of that.
I know what you said. I know what you're saying there. It's going to do jack. It's going to. They don't.
Oh.
They only access their.
Well, right. Okay. I'm sorry. Right. It doesn't do jack in the sense that it does not prohibit people from reading. All right. Thank you. I'm sorry. Okay. Right. It's worse than not doing jack because it's a role that the glance policy file is going to look at it. I don't recognize this, but none of my rules refer to it, so I'm not going to do anything about it. All right. So anyway, hopefully I just haven't made this more confusing. The key point is there is a reader role available, but it doesn't. Remember, the names of these things don't do anything independently of how they're configured in policy, right? So what makes the admin role name do something is that context is admin. You see everybody's file begins context is admin and then role admin is the one that satisfies that by default. So that's what makes it actually an admin role. The name doesn't do anything. So just keep that in mind. The names are completely meaningless. It's how they're configured that matters. Okay, and then I should have flipped to this one sooner. All right, so right, we're creating a new role. We need to, if we want to recognize it as an administrator, we have to adjust that context as admin rule definition. So this is what I was talking about before. So originally it starts just the stuff that's not bolded is how it shows up in the default file. And that's what makes the admin role actually work as an admin. So like I was saying, the services are built so that you can operate in an administrative context. The way you get into the administrative context is by satisfying this rule. And the reason why the admin role satisfies this rule is because it's explicitly put here. So if you removed role:admin from this statement, then your admin users aren't going to be able to do anything. Well, that's not quite true. They'll be able to do normal stuff with their own resources, but they won't be able to act as administrators. Okay. All right. So what we want to do here is if we're going to configure a new kind of administrator, that person has to be an administrator because they have to be able to operate in the administrative context. So we just use or and put in our new role. Okay. And then what that does, that makes anybody with this new role an administrator for the service that is using this policy file. Okay. So we're going to have to plug up some holes. So here's a new policy rule.
Never tell people to use a not role.
Not
role. You can always bypass. You can always drop a role using truss or app threads. So it's not a safe thing to do.
Okay, so be sure to attend the policy how-to to get some better advice for how to do these, right? Because writing a good file is difficult, so you want to make sure that your role is satisfied. So here's one way you can do this that is not recommended, apparently, is we start out with, so if you look in the Cinder file that you generate, you have the default file, it defines a rule called admin API, and that's the syntax of the rule is given there. And then what we want is a rule that's going to exclude readers, so we can make a strict admin API that will match any.
Drop the not and just say role admin. I would say not role Cinder reader admin. Say specifically role equals admin.
Yeah, I can say, okay.
Explicitly whitelist the roles that can do it. Don't do it as a not.
Okay. So something to keep in mind as you go through this. So then once you've got it, you've got to plug up the holes. So let me back up. So assuming that we have come up with a good rule that will do what we want, then you've got to go plug things up. So what you can do is find all the policies that are using the rule admin API, and then change the ones appropriately, right? So you want the, right, so the read-only admin should only be able to do the stuff that's gets, basically. And then for deletes or updates or anything else, you want to make sure you're using the strict rule. So that's the basic sense there. Then you have some more holes, because if you look at the default rule for volume delete in Cinder, right, the rule is admin or owner can do that. And then if you look at the admin or owner rule, it says, is admin true, or some stuff, and then the project ID bit. But the main part is the first thing. So this is what allows an admin to be able to go through and mess with other people's stuff, right? And we don't want our read-only person to be able to do that. So we're going to need another policy rule. So in the Cinder file, we've got this admin or owner policy. We could do this thing that Adam doesn't like and define a strict admin or owner. So the main point here is you need to do it for the administrative functions, and you also need to do it for the regular user functions.
Yeah, I think what I would recommend here is on that first admin or owner, you guys about De Morgan's law earlier. I think that's a really good way to think about it. So specifically say or, and within parentheses, role member. Okay. That's our default for members, and project ID matching. So that's the general guidance that I give, is that you can do the admin override on the left-hand side. On the right-hand side, say the role that you want to have it, and that the project ID matches. And then you don't even need the strict thing. And then the rest of your stuff will work, because you're checking that the admin is true, and then you have the admin role, or the reader role, and then down there is going to bypass. You have to make sure that you're doing it correctly, but yeah, drop the nod and make sure that in your admin or owner, when you're talking at the scale down level, if it's there, and then yeah, you probably would want to have that rule such that you can say whether read or not is across the board.
All right. So the main point is when you have a new admin and you're trying to restrict things, you've got to restrict the stuff that the admin does, but also restrict what regular users do. Because an administrator, by the default configuration, can do administrative type things and also affect end users' resources, because that's what you want an admin to do. All right, and then same deal, you plug up the holes by looking at everybody who's using this current rule and deciding whether you need to use the loose version or the strict version. And then step 9 is testing. And yes, that was step 1, but one of the reasons for doing step 1 as testing was to get a baseline for how administrators should work. Because when you start messing with the policies, it's very easy to take away abilities from somebody without realizing it, and that can make customers upset, and or make your administrators not able to do their job, and that's never very good. So if you've got the baseline for how responses should be satisfied, then you can go ahead and use your test to verify Right, you'll have some new tests to verify that the changes you made do what you wanted, but you also have the baseline tests to make sure that the changes you made didn't mess up anything else you already had. Okay, and then, if I haven't stressed this enough, there's an access control policy hands-on lab this afternoon. If you're interested in policies, I really suggest that you go because you'll get some hands-on experience and there'll be some experts there who can answer questions. Yes?
Question. So, in addition to the testing, is there any kind of thing you can do with onboard service to maybe be more verbose in dumping why a particular user couldn't access a particular object? So for example, you had some standard thing and you couldn't do that. Is there an easy way for you to say, user, whatever, access, this role failed by? I mean, I know you can turn on
right, no, it's
stuff like that, but it's not like a really easy way to do it at a global level.
And you try to do it in a live system?
Yeah.
yeah, it's a logging issue, right? So what you would like is that the reason for a denial be logged explicitly. And in some places in the code that can be done, like right at the API layer, but where you're passing the things around, it starts to get to be a problem. So that's kind of an enhancement request. If things have been designed, so one of the things with Glance, for instance, is that Glance had two APIs for a while that were kind of at odds with each other, and underneath them was a completely rewritten system that passes around a bunch of objects in a very Java-esque way. This is probably more than you want to know. But you basically have these objects that have proxies. You have this onion model. And the permissions are evaluated really low level, with the theory being you didn't want development in the code to affect the way the policies were actually evaluated. Now, the downside of that is that the policies in Glance, some of them map directly to API calls, and others have nothing to do with the API calls, but they have a big effect on whether you're going to succeed or not. So I guess what I'm getting at is just, I'm just giving you an excuse, right? That this is why we don't do it. It's because at the database layer, something's going to get denied, and then it bubbles up, and eventually we know, hey, you can't satisfy this. But we don't know exactly what it was that made it not happen. So if the thing were better designed and hadn't evolved, it's possible that we could do more of what you're asking.
And to just follow up on that, one of the things that we sometimes run into is somebody will log into Horizon and they'll be missing some drop down.
Right.
It's like, okay, why are they missing that? Now you got to go figure out what policies,
File a bug against Horizon data.
But yeah, I feel your pain on that. But not enough that I've actually made code changes for that. Yes?
Have you got a favorite or recommended way of doing those tests?
Come to the lab.
Sorry?
Come to the lab.
Yes.
And do I need to be there for the start of the lab or just turn up throughout?
Depends on how much you want to learn.
Short answer is also there is a tool for Oslo Policy Checker.
Okay, yes.
Actually, one question for Adam. So, talking about this long-lasting advantage with open
Step to the mic.
Oh, yeah.
So I know there is long-lasting
that you were talking about. So has anybody actually managed to implement multi-tenancy in OpenStack? Because we try to set up admins for different domains and then actually have an open ticket with Red Hat, and it seems like there is no way to do it really now. In theory it works, but in practice it doesn't.
Come to the lab. That's one of the things that we're trying to address there. We can go through the policies that we set up there, and you can evaluate. I don't want to give you a yes or no.
Okay.
Because the bottom line is the policies that we're going to be going through in the lab are my best guess, and they really need as many eyes as possible upon them and a community to get behind. Here's what's going to be meant by these things.
Okay.
So that the Keystone folks who understand, the subtleties of, because we're also co-maintainers of Basel policy, and we're writing stuff like app threads. He wouldn't know that you could drop a role because that's a mechanism-specific tool, right? We need to have that kind of communication. So I don't want to say yes or no. I want to say, I think this is what it should look like. You come back and say, hey, you messed this up.
Good, thank you.
All right, I think that's time anyway. So thanks. And don't forget to go to the policy lab.